Okay, section 8.6. So far we've talked about just things in right triangles. And now what we're going to do is we're going to solve for missing sides and missing angles with non-right triangles. So when we talked about right triangles, first of all, if we had two sides of a right triangle, we use Pythagorean theorem to find the other side, right? And then if we knew one angle and one side, we were able to find the other angles and sides by just our trig functions, right? Sine, cosine, tangent. Remember that stuff? Okay. But what if you didn't have a right triangle? How would you solve for the missing stuff? Well, I'm really glad you asked that because I have an answer. Thanks. All right. So I'll call this side A, call this side B, call this side C. Now, to make things work out right for our little formula that I'm going to show you here in a second, if this side is A right here, then look at the angle across from it. What do you think I'll call this angle? If it's across from side A, I'll call this angle A. But I give that a capital letter, right? Because I always give angles capital letters because it's a vertex, right? So that would be A. If this side is B right here, look, the angle that's opposite B, I'll call what? Angle B, right. And if this is C, then this would be C right here. Everybody with me on that? Okay, it's pretty easy to understand. I'm going to show you one law. It's actually two of them in this lesson, but I'm going to split it into 2 days, okay? So I'll call this one the law of sines. S-I-N-E-S, okay? So the law of sines. So guess what trig function is in our law? Yeah, that was not much of a stretch. You're going to have the sine in there, aren't you? So watch how we do this. Now, I write it a little differently than the book does. It makes no difference how you write it. You can do it the way the book does it, or you can do the way that I do it. I just was taught this way, so I'm going to write it this way. Sometimes I think it's easier the way that I write it. Okay, so you might look at it. In my other class, as soon as I started writing it down, hand went up. I said, I know exactly what you're going to ask. And I said, just wait a second and I'll explain it. And I was right. He was asking the exact same question that I was about to answer. But it looks like this. A over the sine of A. And when I say A and A, this is the little a means what? The side A, right. It doesn't mean the angle. Okay, the little lowercase a means the side. The uppercase means the angle. You follow me on that? All right, so it's A, little a, over sine of A equals, and this is easy to remember, it really is, B over the sine of B. Now this is kind of weird. They actually throw a third one in there. And guess what that's going to be? Good. You guys are quick.
Wait, when you said weird, was that sarcastic?
What's that?
You said it was weird that there's going to be a third one.
No, I wasn't being sarcastic. It is kind of weird because you don't usually see three things equal to each other. You usually see one thing equal to something else. Would you agree? But we have talked in another chapter about proportions and stuff like that. And we've had different things. We've had three different sides being, ratios being equal to each other, right? We've had proportions. So we have had stuff that kind of looked like this before. But usually when we have a formula or something like that, we usually don't have three things. But this time we do. But we're not going to actually use all three when we solve for it. We're just going to pair them up and just use two of them. We're either going to use these two, right? Or these two, or what else?
These two.
Right, those two right there, okay? All right, so either the first and the second or the third, or the first and the third. So this is how we write it out because we're relating all these sides. And you look at this and say, well, what does any of this stuff mean? How in the world am I going to use this to solve for anything? Well, again, I'm glad you asked because I'm going to show you. No, it's not a right angle. All right, and I'll mark the stuff. This is kind of what the triangle looks like. I'm taking this right from the example in the book. It's on page 582 if you want to follow along. And they make this side X. They make this one 97 degrees. This little one down here, they make 21 degrees. I'll put a little 21 degree right there. And they make this side right here 16. Now, there is one thing that you can find without knowing anything about law sines or anything like that. Okay, Austin, what is it? Find this angle right here. Okay, somebody do that for me. What's 97 and 21? It's 116. 116. So what's 180 minus 116? I'm sorry, 118. Right, because you add them up, that's an 8. So it's 118. So 180 minus 118 is what? 62, right? Did I do that right? So 62 degrees. That's right, isn't it? Did you double check? Okay.
Yes, it is.
Did you look? All right, anyway, I think that's right. So we got that angle right here. Now this problem says, listen, this problem says to solve for x. So they say specifically what you want to solve for. Now there are some problems. Everybody paying attention? Alyssa, you with me?
Yeah.
Okay, there are some problems that will say this. I'm not going to write this down, but some problems will say solve the triangle. You're like, solve the triangle? What does it mean to solve for a triangle? What in the world do you think they're talking about there? Solve for everything, right? Solve for everything that's missing. So you would solve for this side, solve for this angle. Remember, we didn't know that angle to begin with. So that would be one of our solutions. This would be one, and then what else? The other side, right? So if they say solve the triangle, that means find all the stuff that's missing. Make sense? This one doesn't say that. It just says solve for x. But I just want to warn you that they could possibly tell you to do that. Everybody okay with that? All right. So solve for x. So watch what we're going to do. We're going to use the law of sines. So let's write it down again just so we remember it. The more you write it down, the easier it will be to memorize this. And this will have to be memorized. And that's not hard, is it? I told the last class it's as easy as ABC,
So
right?
clever.
And I had, right, and of course I had people in my last class singing the same song, okay? Little old school Michael Jackson. Yeah. Yes, they know Michael Jackson.
ABC 1, 2, 3.
You guys know Michael Jackson,
They
right?
don't know who's saying that.
Yes. You know Michael Jackson, right, David? Yeah, he did it. When he was a kid, the Jackson 5, he did that song. So anyway, all right, pay attention. So here we go. There's our formula for the law of sines. Now, how in the world do we use this? Remember, we just pair it up. It's not like we use all three of them. We're just using one equals another one. And the letters don't even have to match up. It doesn't even matter. Watch what I'm going to do. I'm going to take, let's say these two right here. I know. You with me? Let's pay attention. I know. I'm not. So watch. Here's what we're going to use right here. Now there's how many different variables? 1, 2, 3, 4, correct? So how many would we have to know in order to solve for one that's missing? You'd have to know 3 out of the 4, wouldn't you? Okay, so what we're going to do is this. Look, this is a side opposite that angle. So I need to know one side, and I need to know the angle opposite that side. Well, look at this. I only know one side on this whole entire triangle. It's 16. Do I know the angle opposite? It's 97. Yeah, so I'm going to use that. Now, what am I trying to find? I'm trying to find x. So guess what I'm going to need there? I'm going to need the side opposite the side, or sorry, I need the angle that's opposite the side I'm trying to find. So let's set this thing up. Let's go what? 16 over, if I use this side, what angle am I using? The 97. So I take the sine of 97. You see what I'm doing there? So I know this side. I look at the angle that's opposite. I know that angle. So I can use both of those. Equals. Now, what am I trying to find? I'm trying to find x, aren't I? So I put x right here over.
27.
That's a 1. It's 21. So I don't just put 21 here. What do I put? Put the sine of 21. Right. It's the sine of 21 degrees. And now, look, I can cross multiply and I can solve.
Easy as lemon squeeze.
It is. Watch. I can now cross multiply. Or, watch this. X is already on the top, isn't it? So really, I could just, why did I pick that color? I meant to pick this one. Okay. This is what we're trying to solve for. I could, in one step, just get rid of the sine of 21. How can I get rid of the sine of 21? It's being divided, so how do I get rid of it?
Sine of negative, the negative
No,
side.
no, no. I just multiply it. Right, this is just a number. The sine of 21 is just a number, isn't it? I'm not trying to get a variable by itself. I'm just trying to get rid of this number, so I multiply it by both sides. So I could put it right here, couldn't I? Everybody see that? Multiply this by the sine of 21, it cancels out. Multiply this sine by the sine of 21. Okay, just happen to have a calculator here. And that's slick. Let's turn it on. Let's clear it. Okay, now how are we going to do the work? Actually, let's do this. Let's clean it up a little bit. Let's say x equals. Instead of sine of 21 times 16, I'm going to write it 16 times the sine of 21. That looks a little bit neater. Over what? The sine of 97. Okay, that's what I'm going to put into the
Do you
calculator.
have to do it like that?
Okay, I have to do it like what?
Like,
Like write it like this?
Yeah.
No, you could just take this and you could cross multiply.
Okay.
All right, you're going to get the same exact thing. Try it. Cross multiply, you'll get the same exact thing. But I got to this in one step. If you cross multiply, it's going to take 2 steps to get to this. All right. All I did was multiply by the sine of 21, and I'm ready to put it in the calculator. Would you agree? All right. So let's do this. Let's go. And the only reason that I went from here to here was just to make it look a little bit neater. That's all. You don't have to write it like this. Let's punch the numbers in. 16. Oh, by the way, I got to remember to do this because I forgot in the last class. If you go to mode on this calculator,
You showed us this.
I know. I'm going to show it to you again. If you go to mode, there we go. What does it need to be in? In degrees. I changed it earlier, but for some reason when I close this calculator out, it automatically goes to radians. But I've kept it on all day, so it stayed in degrees. So make sure that you are in degrees in your calculator. If you have a regular scientific calculator, show your calculator, Rachel. Hold it up. Okay, if you have one like that, it'll automatically default to degrees. You don't even have to worry about it. Okay.
What's radian?
We'll talk about radians in Algebra 2. Okay, we won't talk about radians in here. All right, so let's punch the numbers in. What do you get? You got 16 sine of 21. Now, what if you had a little TI-30, like Rachel just showed you? You wouldn't hit 16 sine 21. You would hit what?
Times
Sine.
16 sine.
No. You,
Oh wait, 21 sine.
you hit 21 first, and then you hit the sine, okay? So on those calculators, you hit the number first, then you tell what function you want to apply to that number, okay? So you hit 21, then sine, you'll get some decimal number. Then you multiply it by 16. Everybody follow me on that? Then you hit equals. After you hit equals, you can hit divide, then you hit 97 sine. But that's not your final answer. What do you have to do after you hit 97 sine?
Divided by the sine.
No, you've already done the division. Listen.
Rounded.
Listen. Look, you got 21 sine times 16 divided by 97 sine, and then you have to hit equals. Hitting equals will give you the answer. All right? So you got to make sure you do that. But this one, all I got to do is this. Divide by sine of 97. And I don't think you have to close the parentheses. I just like to. I hate to have it hanging. All right, so you hit equals, and there it is. So it's 5.77. We'll round it to 5.8, so that's what x is equal to. All right, so that is equal to 5.8. And there you go. In my last class, if you want, you don't have to, but on the YouTube video, you can see it. I got like 35 or something like that, and I looked at it, I'm like, wait a minute, there's no way this can be 35. How did I know that there's no way that could be 35 just by looking at the picture? That's right, because, look, this side right here is opposite 21. It's got to be the shortest side, right? This 16 has to be the longest side. So is there any way that that could be 35? No, so I got to look at it, make sure my answer makes sense, okay? Don't just get a number on your calculator and automatically put it down and think you're right because you used a calculator. You got to make sure you used it correctly. In the first class, I did not use it correctly because I had it in radians instead of degrees. I looked at my answer and said, oh, wait a minute, there's no way that's right, so I got to try it again. And so I thought, you know what I did? I probably didn't change it to degrees, changed it, and then it works. Make sense? All right. Let's do another one. All right, here's another triangle. This time, they're asking you to find x again, so they're saying find x. But guess what x is here? It's not the length of a side of a triangle. What is it?
An angle.
It's an angle, okay? So that's something we didn't do earlier, is it? But we can kind of set it up the same. Now, remember, it's the sine, it's a over the sine of a equals b over the sine of b. Tell you what, if you just want to write it like that, that's fine, right? Because you're not going to use all three anyway. You're just going to use two of them. So, again, it doesn't matter if you have A's, B's, or C's on here, or X, Y's, and Z's, okay? It's just what it represents. This represents a side. This represents an angle that's opposite that side. Make sense? So, really, this is all you really need, isn't it, to do this? Let's see. What are we trying to do? We're trying to solve for X, aren't we? So, we need to find the side, in this case. We're trying to find the side that's opposite this angle X. What side is that? It's 10, right? So those two are going to go together. So what am I going to write? Am I going to write x over the sine of 10? No. What am I going to write? I put the sine, or the length of the side over the sine of the angle. So I'm going to put what? 10 over, talk to me, sine of x, right? Problem is, I don't know what x is, do I? Well, we'll find it. Now, what I have to do now is I got to find a side and an angle that are opposite each other. Do I have a side, S-I-D-E, side and an angle that are opposite each other? I do, 8 and 45 degrees, right? So if the length of the side is on top, the angle's on the bottom, what do I put on top over here on this side? 8 over sine of 45. Good. All right. Are you with me on this? That's enough to start solving for x now. Now, this math is not quite as easy as what we did earlier, but it's not that bad. What's the process? What do we do? Cross what? Cross multiply. So let's cross multiply and see what we get. I like the x to be on the left-hand side, so let's do these two first. It is sine of x times 8, but what's a nicer way to write that? That's right, 8 sine of x. Okay, that's a lot better way to write it, don't you agree? Is equal to, let's do the other one, what's that going to be? 10 sine of 45. Okay? Now let's do some math. What are we trying to do? We're trying to solve for x. We're trying to get that by itself. What's the first thing we're going to get rid of? It's basic arithmetic, basic algebra. The 8, right. How do we get rid of the 8? Divide both sides by 8. So I come over here and divide this side by 8. Now technically I am dividing this side by 8, but I don't think you have to show it now, do you? On the left side? No, I know it goes away. So look what we have now. We have the sine of x equals all this mess right here. I just want what x is equal to. Now you guys were trying to say it earlier. Now what do we do to get x by itself if I'm taking the sine of it?
Multiply with the negative.
Nah, don't multiply by the negative. Right. Now, we're not really going to say multiply, okay? Because the sign is not a number, okay? It's not a variable. It's just a word that describes a certain ratio between two sides of a triangle. So I can't really divide by the sign. I can't do that. But I can take the what? Give me a good word. Take the inverse. Thank you. The inverse of the sign, okay? If I take the inverse of the sign here, then this goes away. So I've got x by itself. Well, if I took the inverse of this side, I got to take the inverse over here. How do I write the inverse? Sine. Sine what? To the negative first. Remember that? And I want you to get used to writing it like that because you're going to see that a whole lot later on in your math career. So it's all this mess again. So I'll just rewrite this. And there it is. Now that's not the answer you're going to turn into me. Okay, that's what you're going to put into a calculator, and you'll get some decimal answer for this. Okay, and then that's the answer you would turn in. So let's do this. Let's turn it on, clear it. Now on this calculator, you do it a little bit differently than you would do on the TI-30. If you had a TI-30, I would do the stuff inside the parentheses first. So this is how I would do it. Watch very carefully. I would hit, I'd probably do this first. I'd probably hit 45 sine, try it, 45 sine, times 10. I don't think you have to hit equals, but I always do. I hit equals, and then I put divided by 8. Then I hit equals. Okay? Then, what are you doing? You're taking the inverse sine of that. So what would you do? Take the second function, not divide, take the second function sine. Sine's not a number. You can't divide by a sine. You hear me? You cannot divide by a sine. But you can take the inverse of it. How do you take the inverse of it on the calculator? Second function sine. So do that, and you'll get the same number as I get right here doing it on this graphing calculator. Now on the graphing, this is what I would do. On the graphing, you kind of go in order the way it looks. So I would hit second function sine right there. Actually, why did it turn off? There we go. Second function sine, right? They already give you that first parentheses right here. Now what do? Hit 10 sine of 45. Okay, I'm going to close that. Now, yeah, that's fine. So it's 10 sine of 45, what? Divided by 8. Close that parentheses. Do you understand why I close that parentheses? Because that one's this one right here. You got it? Okay. What's that? Okay. All right, so that should be good right there, right? Because there's the inverse sine, 10 sine of 45 divided by 8, close the parentheses, hit enter. Is that the same thing you got on your TI-30? Yeah. So 62.1 to the nearest degree. Okay, so we'll say 62 then. All right, and it's an angle, isn't it? Right? It was an angle, so it's 62 degrees. The question says round it to the nearest degree, so we just make it 62 degrees. And that's it. That's the law of sines. That's not so bad, is it? Let me tell you a secret.
I've done it.
You know the first time I learned this stuff?
First, ninth
11th
grade.
grade.
Ninth grade.
Huh?
College.
Who's the youngest in here? 8th grade, right? Huh? Listen to this. It was my. Listen to this. It was my first year of college when I learned the law of sines. I never even heard of it when I was in high school. I was never taught it. Some of you guys are in 8th grade learning the law of sines. I was 20. No, first year of college? I was 18. I was 18 years old when I first learned this. And how old are you? You're 13. So look, you guys are 13 and 14 learning the law of sines. And I still didn't understand it even when I was in college. They had, listen to me, don't talk please while I'm talking. That's really rude. I was, the teacher actually had like extra help sessions and things like that. This was in a pre-calculus class. I was learning this stuff. This stuff is, you're learning this in geometry. I didn't learn this until I was in college taking a pre-calc class. I mean, that's how much further ahead you are than I ever was. All right. So, but it just shows it's not that hard. I was just kind of dumb, you know, because I couldn't get it. I had to go to special help classes and stuff that the teacher had at night, and I still couldn't figure it out. And finally, they just drilled it into my head, and I finally got it, you know.
So if we don't get it, we have to go to special class.
Yes, you got to go to special class. Yeah, special class is held on YouTube at your convenience, and you can watch this over and over again. All right, so there you go. Look, go to Khan Academy if you want. Khan Academy. And I bet you anything, he does a nice lesson. It's .org.
I looked him up
Okay.
on Google and he's young.
Yeah, he's young. He's he's in his 30s probably. Yep.
Last week when you were here, someone did the announcement and it sounded like that con guy.
Oh, did it really? Well, anyway. Anyway, I bet you anything, he does the law of sines, law of cosines. So just as a little twist, just as a little, you know, just to change it up a little bit, take a couple minutes, okay? His lessons aren't that long. His lessons are only like 15 minutes tops. So go on there, look for law of sines, do a search, and see what you can find. And see, he might say things a little different. Now, there is one little thing about the law of sines that we didn't cover. They call it the ambiguous case. All right? We're not going to get into that in geometry. But when you take this in Algebra 2, because you'll see this again in Algebra 2. When you see this again, they'll talk about the ambiguous case, and that gets a little bit weird. All right? So the ones that we're going to do in geometry, they all work out real nice. You won't have to worry about this ambiguous case thing. Right? But when you get into Algebra 2, you'll see that. Khan may actually talk about the ambiguous case. So if you ever look at it and say, Mr. Hamrick, what in the world is he talking about? Well, don't leave before I give you some work. Settle down. There's no need for that.
I've studied on that one. I did.
Why do you even think you can sneak out and get something? Because it's already...
Schedule with our rotation tours on Mondays and Wednesdays.
Watch. 587, 12 to 28.
28.
12 to 28. Section 8-6. Have fun.